Okay, so first of all, what I'm going to do is look at some optimization questions and talk about what optimization is. So, optimization is just being able to work out um, a maximum or a minimum in a real life problem. So, places where maximum and minimum occur in real life problems are things, for example, like if you projected an object and it reaches a maximum height, just like projectile motion. Being able to use calculus to actually find the point at which this happens is what we call like an optimization question or maximum minimum real life problem. Okay, now we know at that point that's where the gradient is 0. So when we're looking at these questions, what we're doing is we're actually looking to set up equations. So we set up equations that model real life situations. And then what we do is we use calculus to actually work out where the maximum or the minimum is in that real life situation. Okay. So in the syllabus, solve optimization problems of functions covering the scope of this syllabus. Displacement, velocity, acceleration, area, volume, business, finance, growth and decay. So it comes up in lots of different areas and there are a lot of different types of problems. So if we look to find the variables, construct a function, get the relationship between the two variables, and then use calculus to locate the global maximum minimum, evaluate solutions and the reasonableness given the constraints. So make sure that, if it's length, then you get a positive value. And that's actually what we did today. So some typical like calculus problems that you could have, the maximum height that a ball reached, and maybe looking at, if you're looking at a garden and building a garden and you have particular restraints on the fencing and you want to maximize the area. Vice versa, you might want to minimize the amount of fencing given a particular area or paddock that you're building. So maximum problems come in 2 steps. First, you have to create the formula. And second, you have to use calculus and the differentiation rule to find out where the maximum or minimum points are. Creating a rule for the formula, we're going to do that first. Okay, so to create the rule, you've got to really keep an eye out on what do you want to maximize or minimize. So sometimes when you're doing these questions, look at the end question and that will tell you what your focus is. Is it area? Is it volume? Then you look at creating a rule for this. Now, in order to create a rule, a lot of formulas like V equals R squared H, that formula is in terms of 2 variables. You have V in terms of 2 variables. If you're going to use calculus, you have to have it in terms of 1 variable. Then you're able to find like V dash, for example. So there'll be some other information, which will be the restraint on the 2 variables, maybe given the perimeter, given the area, given Pythagoras, maybe similar triangles, that will help you find a relationship between those 2 variables. Then you solve for one of those variables and you sub it into your main formula. So you can write a formula in terms of 1 variable. Okay, so we're just going to look at, first of all, just creating the formula. So a rectangle has a perimeter of 200 meters. So there's my rectangle. Its width is X and its length is Y. So we have to show that Y equals 100 minus X. So if we look at this, this is X, this is Y. So X plus Y plus X plus Y equals 200. 2X plus 2Y is 200. 2X is 200 minus 2y is 200 minus 2x. If you divide by 2, then you get y is 100 minus x. Okay, so that there is, that just answers the first question. It gets 1 variable in front of the other, in terms of the other. Okay, and then the second part, which is B, what we want to do is we want to find the area just in terms of x. So the actual area will equal y times x because it is base times height. So it's y times x. but we want this all in terms of x. So what we do is if you get this rule here, this formula, and you move it over, and where the y is, you put 100 minus x times x. Then when you expand that, you get 100x minus x squared, and hence we've got the area just in terms of x as required. Okay, looking at this one here, we have the area is 50 meters squared. We want to show that the perimeter is 2x plus 100 on x. So if you're getting the perimeter here, that would be 2x plus 2y. So at the moment, it's in terms of two variables. We have to get rid of the one variable, which is the y, because if you look at our prize, this is our prize, it is all in terms of x. Okay, so that means that we go, all right, well, the area here is xy, so therefore xy equals 50. So I can make y the subject, so it's 50 on x. So the perimeter is 2x plus 2, 50 on x. So the perimeter is 2x plus 100 on x, because that's 2 over 1, which is as required and what we have. So it's like using this one, using one bit of information, which is the area, writing what the perimeter is in terms of two variables, replacing the y value with what it equals, and then you have your formula in terms of just the one variable, and it's all ready to use calculus on and differentiate. So number 3, we have a rectangular paddock. The perimeter is 120, so that's your bit of information or your restraint. We're going to call this x and y. So we're talking about the area here. So the area is x times y, but it is in terms of two variables, so we need to get rid of the y. So let's use that the perimeter is 120. The perimeter would be x plus y plus x plus y. X plus y plus x plus y equals 120. So that means 2x plus 2y is 120. X plus y is 60. So y is 60 minus x. So what that means then, the area equals xy. So x times, now what is your y? Your y is 60 minus x. So it'll be x times 60 minus x. When you expand that, you get 60x minus x squared. Okay, and that was your given area. Okay, looking at example 4. So we're not doing the calculus part here, we're just getting the formula. So this is our restraint, that the volume is 400, and this is the prize, the surface area. So the volume of a cylinder is pi r squared h. The surface area is 2 pi r squared, because that's the two circles at the end, plus 2 pi r h. Now, if we want to get this whole surface area, and I've got too many pluses here, all in terms of r, and I should really be using little r, 2 pi r squared plus 2 pi r h. Okay, and you can use a for surface area, that's all right. So if I take the volume that is here, and I make 400 equal pi r squared h, then I can get the h. The h will equal, if I change the subject, I can get h in terms of r. Then all that is required now is to get that h, and all that I have to do is sub it into there. So it's 2 pi r squared plus 2 pi r times 400 on pi r squared. You can now cancel. R goes into r once, and that one will cancel. And the pi's will cancel. So the area is 2 pi r squared plus, that 2's on top, 2 times 400 is 800, and it'll be 800 on r as required. So we're always getting whatever our constraint is or our restriction, the condition, restriction, or the condition that it is, like the volume is 400, using that to get a relationship between the two variables, solving for one of the variables, subbing it in to the equation that we're trying to get, all in terms of one variable, and then simplifying to get it in terms of one variable. Step 2, finding the maximum minimum of the formula. So Once you have your formula set up or your rule, you differentiate, make it equal to 0. So differentiate, make it equal to 0. It could be like, a dash equal to 0 because a is in terms of one variable. Solve for could be x or r or x equal a or b. That's what this part is. Check whether it's maximum or minimum. So you get 1 mark for differentiating, 1 for solving for the a and the b, and then you have to check if it's a maximum or a minimum. And to do that, you can either use a table if it's hard to find a dash, or you can use a double dash. And if a double dash is greater than 0, it's a minimum. If a double dash is less than 0, it's a maximum. But what you need to do is you need to sub in the value for the maximum or minimum. You're not always interested in the 2 values here because one will be a max and one will be a min. So have a think about which one you think would be the max and which one you think would be the min. Okay. And then, if it's a minimum, it should go from negative to positive, a maximum from positive to negative. And which one do you use? You use a double dash if it's easy to find, or otherwise you've got to go back to use the table. Okay, so let's look at some questions here. All right, so I got this one here. A rectangular block of land is 160 meters in fencing. So we're going to use 160, that's the perimeter. So let's use the rectangle, that's x, y. I'm just going to add a page because I feel for this question I am going to need an extra page. Okay, and I'll just put some paper. Done. Okay, so that's y, that's x. So this will give our relationship. So we have 2x plus 2y, 2x plus 2y equals 160. So this allows us to get x in terms of y, and y equals 80 minus x. So that's, y in terms of x, so that's part A. Part B, we need to get the area. So the area is xy, which is x times 80 minus x, which is 80x minus x squared. Okay, and that allows us then to answer this question. This one here answers the first part. Now for the third part, that's the calculus part, you want to find the maximum area. So in order to get the maximum area, you differentiate this. So that'll be 80 minus 2x. Make it equal to 0 and solve. 80 minus 2x equals 0. 80 equals 2x. X equals 40. Then you have to check if this is a maximum or a minimum. Now, a double dash here is very easy to find. So you look at it, you get minus 2, less than 0, therefore it is a max. Okay, and then what you want to also do is answer the question. There'll be another mark for answering the question. This one wants the maximum area. So the dimensions is when x equals 40. It doesn't ask you to find the width or the length, like we're not after that. We're after the maximum area. So you have to go back to your original area question and just put the 40 into there. They get 3200 minus 1600, which is 1600 meters square. Makes sense, it is a square, because if you look at the y value is 80 minus x, y is 80 minus 40 is 40. So if you've got a particular perimeter and you want to find a maximum area of a rectangle, it does turn out to be a square, 40 times 40. Okay, so we're now looking at question 2. So question 2, I'm just going to look at this one. Okay, so we have a restriction on here now. This one has a river, that is x, we'll call that y, and that's x, and it's a rectangle. So the perimeter of this is 160 of fencing, so that's just the x plus the y plus the x. So that means 2x's plus y is 160, y is 160 minus 2x. Okay, Now part B, we want to get the area. So the area is just x times y because it is just length times width. So we want it all in terms of x. So we get out what the y equals and we sub that in. So it's 160 minus 2x. The area is 160x minus 2x squared. Okay, so that's the area. All right, so the question says they want the maximum area for this block. So you differentiate, which is 160 minus 4x. Make it equal to 0 and solve. So 160 minus 4x equals 0. 160 equals 4x when you bring it over. X is 40. You sub into the original. Okay, so actually we don't need to sub into the original yet because that would be when we are answering the question. So only if needed. So we know the width is 40. So we have to check if it's a maximum or a minimum. Now it's very easy to differentiate twice. So differentiating that, you get minus 4x, which is less than 0. Less than 0, that means it will be a maximum at x equals 40. And then make sure you actually answer the question. Find the maximum area of the block of land. So they want the actual area. So the area, let's go back to the area formula. It's that one. I'm going to take out the 2x because it just makes it easier to calculate. So it's 2 times 40, 80 minus 40. So that's going to be 80 times 40. So we've got 3200 meters squared. Okay, so I am just going to stop the video and we're going to come back a bit later